So this is the second part to lesson 6.5, trigonometric functions. In the previous lesson, we looked at determining amplitude of a trig function, determining the period of a trig function, and determining the phase shift of a trig function. Today, we'll complete the section by identifying transformation of the graph of a sinusoidal function. Essentially, we're looking at the amplitude, the horizontal stretch or compression, the horizontal translation, and we'll add today the vertical translation. In the previous lesson, we looked at the general equation where we have y so the general form of a sinusoidal function is y is equal to a sine b x minus c. That's what we looked at the last time. Today we're going to add d, which is your vertical translation. So a is your amplitude. And we say the amplitude is your maximum value minus your minimum value divided by 2. Okay. So B is your horizontal stretch. So horizontal stretch or compression. Which is 1 over absolute value of b. C says the phase shift. Essentially, it's the horizontal translation. And D, which we'll add, is your vertical translation. We also said that the period is equal to 2 pi over the b. And vice versa, d is equal to 2 pi over the period. Okay. Or 360 degrees over b. So we'll put all of these together and to answer the assignment questions. Let's look at the first one. And here we're looking at amplitude, the horizontal compression, and the vertical translation. So y equal 2 cos. Here's my cos, and the amplitude of 2. So we have the amplitude here. So you multiply by 2. So the amplitude is equal to 2. In other words, a vertical stretch. By a factor of 2. So if you were to look at this graph here, we'll go from 2. So it will go down and down and back up here. So y is equal to cos x. The amplitude is 2. Here, we don't have an amplitude that's different from the original cos graph because it is still 1. But here we have a compression by a factor. So b is equal to 2. So the compression is 1 over 2. So we have a horizontal compression by a factor of 2, of a half. So we have a horizontal compression a factor of a half. So from this here, we can derive the period. Now, the period is generated for the general one is 2 pi, but here is a period. So I'll put that here. Y is equal to cos 2x. B is equal to 2. The period is 2 pi over the b, or 2, right? So we know that period is 2 pi over b. So now the period is actually pi. So it's compressed half of what it was. So it's 2 pi. So it's now, instead of 2 pi the period is now pi. So the cos graph now, if I were to do that in a different color ink, maybe I'll try a blue. So here, the period ends here. So we have 1, 2, 3, 4. So now we start still 1. So actually, let's do it the one below here since I already have the graph here. So we have 1 and negative 1. So my original cosine graph looks like this here. Oops. But now, it's now a period of 1. Here's a period of 2 now, it's 1. So now my points are going to be 1, 2, 3, 4. So this now is y is equal to cos 2x. Then if you would continue, I'm going to go back here, you'll see it will be 2 periods in 2 pi. Oops. Now we have, if we look at the next one now, we have an exact graph as the cos, except now it's a vertical shift of -2. So instead of the midline being here at 0, the midline now this graph all shifts 2 units down. So now we go from 2 to here, and from 1. So we're shifting 2 units down. So we start from here, here. And so the midline, instead of being here, will be at -2. So now here's my new midline. So here we have -1 and -2. So midline. So y is equal to -2 is the midline. Essentially, when you have your translation from the original, this will give you your new midline, which is now -2. So we start here at -1. So we have pi over 2. Then come down. So now this graph now is y is equal to x of sine x minus 2. So go back to original. So your D is a vertical translation. If it's negative, it's units down. If it's positive, units up. Here's another set here. So for 3 sine x, we have an amplitude of 3. In other words, a vertical stretch of 3. So for y is equal to 3 sine x, we have a vertical stretch of 3. or the amplitude is 3. So if we were to look at our regular sine graph, we have 1 and -1 here. So our graph going up. So in this case, now we're going to go, maybe I'll here, down there. Now we have -2, -3 back here. So see, y is equal to 3 sine x. This indicates it's 2 pi or 360 degrees. The next one, we're looking at your horizontal stretch. This is your b. So b is equal to 3. So this would be the horizontal stretch would be 1/3. So we have a factor of 1/3. So the graph so y is equal to sine 3x. So the graph y equal to sine 3x. You have a horizontal compression of 1/3. Or what we knew now, for the period, now the period is now 1/3 of the original, right? So you can find the period by 2 pi over b, which is 2 pi over 3. So now the period is 2/3 pi. Okay, instead of having a full 2 pi as the period now, it's actually 2/3. Okay, because it is 2 pi over the value of b. So we have the entire period now. It's somewhere about 1/2 pi, 3/4 pi. So we know it's somewhere about here. Is the period. So we have a compression. So we have half. So we have, instead of this graph going all the way there, now we have a period of sine going up here, coming down, then down here, approximately. So the period is 2/3 pi, or the compression is 1/3. And the last one, here we have a vertical shift of 3. So here is my 1 and 1, -1. So if we have a graph, this is my regular sine graph. So y is equal to sine x. Here we have a vertical translation. So y is equal to sine x plus 3. So we have 3 units translated out. So 3 units translated, 3 units up. So instead of it being here now, you're going to shift 3 units upwards. We have 1, 2, 3. So we have 2. So now this becomes a midline. And so we have points here, there. Okay, so we go up, down. Oops, now look at this. Doesn't look right. This should be here. So this is y is equal to sine x plus 3. So essentially we're using this fact here to help us along on the period. These are some questions from your discussion. What is the essential characteristic of a periodic function? So we have the graph repeats at a regular interval. So that's what a periodic function is, right? The graph of a function repeats at regular intervals along the x-axis or the horizontal axis. So they ask you, how can the unit circle definition of a sine cosine ratio for an angle be used to define the corresponding trig function of a variable that is a real number? So the coordinates of points on the terminal arm is what we use. So remember, I'll go back to, so coordinate points on the terminal arm, so the x is for cos and the y is for sine. So the coordinates of the points where the terminal arm of the angle in radians, right, intersect. So cos is your x and sine is your y. And that's going to use for to get your sinusoidal function. Going through some of the assignment questions. 3, the amplitude. Identify the amplitude. The amplitude here is 5. So that's your amplitude. The amplitude here is 2. It's basic ones. The period here, remember period is 2 pi over b. So this is your b here. So this is 2 pi over 10, which is pi over 5. The period is the same thing here, is 2 pi. Oh, for tangent now, it's pi over b. So for the period, for tangent, it's pi over b. Because remember your tangent is undefined at 90 degrees or pi over 2 and 270 degrees or 3 pi over 2. Pi over 10 over 4. That's a period. The phase shift, let's give it here. So it's, if it's negative, so the phase shift is pi over 7. And the phase shift now is negative. Negative pi over 12. Okay, so here for each of the function below, sketch a graph of between negative pi and pi. So here I have a cos graph, but I want to go from negative pi to pi. So this is my regular, and you can use as a guide to help you. So this is your graph for a regular cos, y is equal to cos x. Now you extend this graph to negative, so it will be extension of it. and you continue. So it's made 1 here. So this graph actually starts from here, goes up, down, and ends there. So I'm going to remove, oh, I did that in ink, so that wouldn't work. So this is my graph, begins and ends here. So one way of doing it is to use this graph here as the regular coast, and then you can extend left or right if they ask you to extend the graph. The domain is increased. Now they ask you the amplitude here. Amplitude is 1. The zeros are pi over 2 plus or minus pi over 2. Let's see, it's increasing, right? We're decreasing by pi over 2. So the zeros, right, is plus or minus pi over 2. This is increment on the, in other words, what are the x-intercepts? And because it's, here we go, from here to here we have pi over 2. So here it increases by pi over 2 each increment of zeros. The domain would be all the real numbers because it's, in this case here, the domain is from negative pi to pi. Okay, so the domain, so in this of this function, so we set it, so x is between pi and negative pi. The range is from 1 to negative 1. There's no asymptote, so none. The period is 2 pi. Because from here to here is pi, and then you have another pi here, so it's 2 pi. Okay, just 2 pi. Okay, let's go on to the next one, sine x. Now I've already completed sine x now, but they want you to extend this graph. Oh. So between 2 pi, oh no, sorry, between pi and 2 pi and negative pi. So continue this graph. So it will be, so that's my graph now. So it ends at this point here. Now I should have done this in pencil, and I would have erased it, but I did it in pens. Okay, so the graph, this graph doesn't exist there. Just I'll use a marker to indicate. There you go. So that's your graph. So the amplitude is 1. The period is 2 pi. And you can tell this indicates as long as x is 2 pi or 360 degrees, they ask you for the zeros. So the zeros are what we have, negative pi plus or minus negative pi. Plus or minus pi, I should say. We have 0 here. So these are our zeros because we're restricted to these points here. Okay. Well, let's ask us here. Zeros, periods. Go back here. Oh no, there's no asymptotes. And the range is from y is less than or equal to 1, greater than or equal to 1. And the period is 2 pi. That's from our graphic. This is a tan function, and there's no amplitude because the graph goes up forever. So tan, so no amplitude. Now the zeros, if you're looking at between pi and positive pi, the zeros are at pi, plus or minus, and 0. So zeros are minus pi, 0, and positive pi, or plus or minus pi and 0. The domain, now notice that its all x value is where x plus or minus pi over 2. Right? So it would be x where x is not equal to plus or minus pi over 2. Because at every pi over 2 intersection, it's not equal to this point here. The only x at the pi. Notice at pi, if you were to go here, this would be another the period is pi. Goes from here to here is one period, it's a pi. And the range is all the real numbers. Oh, sorry, the range y should be y, can be x. And there's an asymptote here. The asymptote is where x is equal to, here we have pi over 2, where it's not equal to actually. Now, question 6 using a graphing calculator, or you can use Desmos. I'll let you go ahead with those questions. Now, the next part is also on sketching. And for all of these here, this is a vertical shift of 1. So if I were to sketch this graph now, it shifts 1 unit up. So my midline would be now there. So the period is still 1. So it will be is cos. So we start from here. So we have our pi coming down here. So we half weights here. And it's 1 unit. So we're going to go down here and back up. Now, and oops, and this is going to continue on the other side too. Okay. This means it's continued. So remember, this is amplitude of 1. So that's why I do this here. Amplitude of 1 and a vertical shift of 1. So I know my regular sine function, what it looks like. And all what I'm doing now, I'm just shifting up 2 units. Sorry, 1 unit up. Okay, it should be 1, will be down here. It's my regular, oh, that's my cos, that's my sine. Sorry about that. I'm jumping ahead, I'm looking at the next question. So it's actually up here, down. down. So that's your cos. Now the next one is a sine function. So what I'll do, I'll use my regular sine is 1, 2. Here's my 4 points. Start from here. So it goes up, goes down, then so that's my sine function. It'll repeat, and this goes on and on. Now this is now the phase shift. The amplitude is still 1, but here, sorry, horizontal. Here we have a horizontal compression, right? Horizontal compression of by a factor of a half. The period then is half of the normal one, which is 2 pi over 2, which is pi. So now instead of having the period here, 2 pi, now it ends here. So now we have to be here. Here's how we have our sine function is up, and here, come down. Oops. So we have, and this will continue. Okay, we have so this goes up, comes down. And oops, and it repeats. Now this one here is a cos. It will be a horizontal shift. So horizontal shift pi over 3 units to the right. So here's our cos graph would look like. Oops, here we go. That's our cos graph, but now you're shifting pi over 3 units now. Instead of starting from x at 0, it's now beginning from here. So everything shifts now 3 units to the right. So that will look like, start from here, goes down here. So we're gonna go, then we have this point here. Then 4/3 pi, just down here. And we have it here, and go. So this one here is y is equal to cos x minus pi over 3. Oh, we have one more, 2's. Now this is an amplitude. So here we have our sine function. Here we have a half. So here would be your normal sine graph. But now it goes up 2 units. So we're gonna 2, go down 2. So our graph looks like this here. Now this is y is equal to 2 sine x. And by the way, this will continue. This graph will be continues here, and it goes. So it continues by the 2 sine x. The other ones looking at technology, I wouldn't, you can use Desmos for these questions. Okay. So that ends this lesson and this is a summary. Just remember the amplitude is the midline to the maximum, midline to the minimum. The midline is halfway between the maximum and the minimum. The period for a standard y equals sine theta or y equals cos theta is 2 pi, and the y-intercept result is 0. In this case, the range. The period is 2 pi over b. So the cos graph looks as a shift relative to a sine function. So it's the same as, in terms of the period, it's 2 pi, the amplitude is 1. So y is equal to cos of x, so theta. The next lesson, we're going to look at combination of sinus of translation. So instead of just looking at one, we're looking at a combination of translation and compression. So we'll take what we've learned today, extend it. So this is what we've looked at today. We'll have this graph, but we'll have a combination of transformation, translation, and compression. So we're looking at amplitude would be vertical stretch or compression. We're looking at B, horizontal stretch or compression. C is your horizontal translation. And D is a vertical translation. At this point, you'll want to complete, if you look at your booklet, you would like to complete lesson 2. And looking at, here you got the amplitude, domain, and range. So remember, this got the amplitude, the domain. If there's no restriction, it would be all the real numbers. And the range will give you, look at your amplitude. That will give you your range. So that'll be the same thing at the period. Remember, period, it's, so we go. The period, the only thing difference, right here, looking at the period is 2 pi over b. The amplitude is always the maximum minus your minimum divided by 2, which is on the previous page. So you'll use the definitions or the equation. So amplitude, period, and that will give you the range. And then we did a phase shift. The phase shift is the C component of the standard equation. So you're looking at the standard equation, the phase shift, meaning the horizontal shift, the vertical shift, amplitude, and this is your compression. The amplitude is your vertical or vertical compression or stretch. Your B is your horizontal compression and stretch. And remember, your B is 2 pi over, the B is how many cycles in one circle, or 2 pi. So this you want to complete this section for the next minute. Next lesson, we're going to look at more into sketching graph. We've done some of it, but you can attempt it. But the next lesson, I'll be going over some sketching of graphs with all functions. And the last part of it, we'll be looking at when you're given a graph, find its equation.